Stack organization concept. A stack is a last-in first-out LIFO data structure that plays a crucial role in computer architecture. It functions like a stack of plates, where you add plates referred as data on top and remove them from the top as well. Implementation. In the context of CPUs, a stack is typically implemented as a dedicated memory area or a set of registers. A special register called the stack pointer (SP) keeps track of the address of the topmost element, often referred to as the top of the stack. Operations. Push adds an element or data to the top of the stack. The SP is incremented to point to the newly added element. Pop removes the element at the top of the stack. The SP is decremented to reflect the new top element. Instruction formats. Instruction formats define how instructions are encoded in a machine's memory. Different CPU architectures use various instruction formats, typically classified by the number of operands refereed as data values explicitly specified in the instruction. Zero address instruction. Stack-based, no operand fields are present. Instructions operate on the top elements of the stack, such as implicit operands. Example: add instruction pops two operands from the stack, adds them, and pushes the result back onto the stack. Advantages: simpler instruction format, efficient for LIFO operations. Disadvantages: less flexible for complex instructions requiring specific memory locations. One address instruction, one operand field is specified. The instruction typically uses an implicit register, for example, accumulator, and the specified memory location or register for the operation. Example: add X instruction adds the value at address X to the accumulator. Advantages: more flexible than zero address but simpler than 2 and 3 address. Disadvantages: limited operand flexibility compared to multi-address instructions. 2-address instruction, 2 operand fields are specified. The instruction typically performs an operation between the 2 operands, possibly storing the result in a register or memory location. Example: add X, Y instruction adds the values at addresses X and Y, storing the result at location X or another specified location. Advantages: more flexible than one address, suitable for many operations. Disadvantages: can be less efficient for LIFO-like operations than stack-based. 3-address instruction, 3 operand fields are specified. The instruction explicitly states the source operands, the operation to perform, and the destination for the result. Example: load X, Y, Z instruction loads the value at address Y into register X, and stores the value at address Z into another register or memory location. Advantages: most flexible instruction format, allows for complex operations. Disadvantages: less compact than other formats, potentially less efficient for simpler operations. Notations. In computer organization, various notations are used to represent data, memory addresses, and operations. Binary numbers, instructions and data are ultimately stored in the CPU's memory as binary numbers, i.e. sequences of zeros and ones. Hexadecimal numbers. Hexadecimal having base 16 notation is often used for human-readable representation of binary data due to its efficiency, i.e. fewer characters than binary for larger numbers. Assembly language. Assembly language provides a symbolic representation of machine instructions, making them more readable for programmers than binary or hexadecimal code. It is typically translated into machine code, i.e. binary instructions by an assembler. High-level languages HLLs, for example, C, Java, Python offer a more programmer-friendly way to write code. They are compiled or interpreted into machine code that the CPU can understand. Let's solve some multiple-choice questions. What is the primary operation of a stack? A. First in first out FIFO. B. Last in first out LIFO. C. Random access. D. Sequential search. Solution. B. What register keeps track of the topmost element in a stack organization? A. Accumulator. B. X register. C. Stack pointer. SPD. Program counter. PC. Solution. C. Which instruction format does not explicitly specify any operands in the instruction itself? A. 0 address. B. 1 address. C. 2 address. D. 3 address. Solution. A. What is the advantage of a stack-based instruction format? A. Increased flexibility for complex operations. B. Efficiency for last in first out LIFO operations. C. Easier addressing of random memory locations. D. Reduced instruction size for simpler operations. Solution. B. What is the trade-off of using a 3-address instruction format? A. Less efficient for LIFO operations. B. Limited operand flexibility. C. More compact instruction size. D. Less flexibility for complex operations but more efficient for simpler ones. Solution. C. What notation is most commonly used for human-readable representation of binary data in computer organization? A. Decimal. B. Octal. C. Hexadecimal. D. ASCII. Solution. C. What is the role of an assembler in computer organization? A. Defines instruction formats for the CPU. B. Translates assembly language into machine code. C. Executes machine code instructions. D. Manages memory allocation for programs. Solution. B. How are high-level languages HLLs typically translated into instructions the CPU can understand? A. Directly interpreted by the CPU. B. Compiled into machine code or interpreted into bytecode. C. Manually translated into assembly language. D. No translation is needed. HLL code is directly executable. Solution. B. What is the main difference between assembly language and a high-level language HLL? A. Both offer the same level of abstraction from machine code. B. HLLs are closer to human language, while assembly is closer to machine code. C. HLLs are more efficient than assembly. D. Assembly languages are easier to learn than HLLs. Solution. B. What is the primary focus of computer organization? A. Programming languages and algorithms. B. Design and architecture of computer systems, including CPUs and memory. C. Operating system functionalities. D. User interface design and interaction. Solution. B. Thank you.